My colleague Dario will join us shortly, and we come here to discuss an issues we are occurred by introducing an on-prem cloud ID in our organization. Firstly, just a quick poll. How many of you are actually using cloud ID in your organization? Okay, we have one, but that actually means that other will learn a lot on this talk. Just begin. My name is Dario Sinic. My colleague is Dario Postric, and we actually come from Apis IT, which is a state-owned company. It actually have a lot of projects included regarding the taxing customers and financial services. Let's start with actually what an IDE is. The quote from the real programmer, don't use Pascal, as a sarcastic book from 1983, actually says that a real programmer has to do his work in a text editor. That's obvious, but that text editor has to completely reflect his personal style. That's one of the reasons why we have an ID wars over the years. So this is the first. That's the ID. That's familiar with most of you. But what is actually in the cloud? The cloud computing. The computers can't actually fly, but the word cloud it's probably an advertisement trick because it represents something mysterious, far away. But in our case, because we are actually using on-prem, it's someone else's computer. And in this case, this is our own. We don't use the AWS, Google Cloud Provider, or Microsoft Azure. So how this actually works? Everything you do is you just open your web browser. After that, you connect to the cloud. And there, the container spin up your developer environment, and all drivers and development kit is actually inside of it. You don't need to install nothing on your workstation. So what are actually types of cloud ID? There are actually two types. The first one is actually not many people remember it. But it's actually notebooks. They actually originated from 1988. It's a long time ago. From mathematics, it's from Stephen Wolfram. And his actual quote is that it took a really long time to actually those concepts being copied to all other notebooks, such as Jupyter Notebook and RStudio. But today, Jupyter Notebook was started in 2013, and from that we have three popular, the most major notebooks cloud provider. It's actually Kaggle, Gradient, and Google Colab, and both of them actually can provide you to use graphical process units to power your notebooks. But that's actually being used more in the machine learning community, not actually in the development web community. So there's actually a second type, and it's classical ID. So if you want to move a classical ID in a browser, it's really difficult job, and there has been past many years. And we waited all the way until 2013 and for the election. Actually, the election made it possible to write code in actually JavaScript, and then port the application on many other operating systems. But the thing is that you can actually run it in your web browser, because the Electron is a small web an Electron application is a small Chromium-based application. And from that, the Visual Studio Code was created in 2015. That's from Microsoft side. And from the open source side, there is an Eclipse TIA from 2017. And on the top of that, today there are many other products which added on top on that layer, the infrastructure as a code, the role-based access credentials, and many other features which are actually on a whole platform on top of it. So, in comparison to Workstation to Cloud IDE, on Workstation we are an admin on our station. We are God. We can do anything else. We can do anything. We can customize it pretty much anything we want. There is no need for internet connection. On my recent flight, there was a guy in an airplane sitting right next to me who was coding. He can do it if he is using a workstation. And there is, of course, a variety of options. By variety of options, I mean different programs of editors he can choose. But on the Cloud IDE, the advantages of it is actually a fast setup. It only needs to be set up on the cloud, and the other programmers are actually connecting it to it. The configuration drift, it's actually reduced. The Cloud IDE helps to reduce the configuration drift. The configuration drift is the term that represents that if you have a driver on your laptop that it helps you connect to the database, you have to maintain it, you have to upgrade it. And if there are a lot of workstations, it's actually pretty tedious task to keep them maintained and at the same version. But in the Cloud IDE, you just have to put it in the container image, and it will spin up every single time. And actually, collaboration, if you're using it in the web browser IDE, it's much easier to share your screen with others and actually to see the cursor of your buddy programmer. That's actually like in the Google Docs. And of course, your fans won't wake your household in the middle of the night, because everything that's actually done in the Cloud IDE is actually done on the cloud side. It's not done on your laptops. So your CPUs won't spin up. We decided to use on-premise. Why is that the reason? We are actually a big firm, and there is availability of local machines. So why not? It's easier for the security, because if it was on the cloud, then we would need to create a tunnel for it to be totally secure, because we are talking about source code, which is actually an intellectual property of a company. It's something that the company makes money from. And it's actually a lot cheaper. The licensing model in the cloud is actually based on the number of users and the number of CPUs and disk and RAM that is provided. But in this case, the only factor that can be licensed is the number of users. The complaint environment is on us to deploy it. And something that Danica was speaking this morning is the cloud outage. It's quite tedious to deal with that, and it's tedious because it's not announced, and we can't do anything about it. So everything started with a team of brave 7 individuals who took the road from classical Workstation IDE into the cloud. They were previously developing stored procedures in PL/SQL. That's actually an EGL scripting that's it's later compiled to COBOL and then run on ZOS in batch mode. Because they were connecting on an old and in various databases and external sources, there was need for a lot of drivers, and that was actually the configuration drift that I was talking about, and that was the perfect solution for them to move to Cloud IDE, and actually to get rid of the EGL and COBOL, and to move to something much modern that is actually Python. And just to think that COBOL is not around us, so there is a video from Elon Musk actually explained about it from his experience in PayPal.
Is really a bunch of heterogeneous mainframes running old COBOL.
Okay, you mean literally? That's
literally.
That's literally what's happening.
In batch mode. Okay.
In batch mode.
Yeah, and I pity the poor bastards who have to maintain that code. Okay, that's a pain. That's pain.
Not even Fortran, it's COBOL. Yep.
It's COBOL.
So pity the poor bastards who has to maintain that code. So actually, and after 2 years of developing in Python, they were put on day one in the cloud, and there were zero issues. So from a deployment perspective, from dev environment into the production environment. And actually, it's completely the faster. The whole process from getting to the dev environment to the production environment is decreased, and that actually helps us to bring our products to our customer much faster. There is no need for special admin privileges on the laptop because there is no need for any installation. There's also a faster migration to newer laptops because everything is in the cloud. He only has to log in to the cloud IDE. And when we are talking about cloud or actually on a computer in our system, a lot of developers are actually using those computer systems. So we can divide those resources into borrowable, something that can be borrowed but then returned, and something that can't be borrowed, something that is taken and not returned in a long time. Something that is borrowed is actually in CPU. I will borrow it just to run my job, and then I will return that. It's actually, what can we do about it to actually increase the capacity of it? We can turn on the hyper-threading, which is probably turned on many of systems. From the memory and RAM perspective, we can turn on the overcommit in Linux kernel to 1, which actually means that you can allocate much more RAM than is actually physically available. So how is this possible? That's possible when the process is forked. This actually means that the twin process is created, but the complete memory that he allocated is not replicated, but it's only replicated at the change of the first one. So it's actually copy and write mechanism. And then we come to sadly, to the unborrowable resource. That's actually disk. What is stored on the disk? It's mostly source code and modules. Source code isn't quite big. So that's not a problem. But the modules, they can be quite large. Especially here, we are talking, especially here in the Node.js, but Python, Golang, and many others aren't exception. So we have a really big issues regarding to the disk, and it's in the borrowable resource we can easily cap developer in the CPU and memory, but it seems unreasonable to cap it in the disk because on his workstation he has a 1 terabyte disk. So why would we cap it there? So what can we do actually about it to utilize as much as little as possible disk space? And that about that will talk my colleague Daria.
Thanks. Thank you, Dario. So let's look at the file forensics and see how we are basically using our data in this our scenario. So we have 2 to 5 people that are that are working on the projects, and basically we have multiple projects that are using the same modules and the source code, and this is done repeatedly. Because of that, we basically have a bunch of text files and binary data, and we know that text files and binary data are basically you can compress them very well. So what kind of file system do we need? What kind of file system is best for our use? As we have said, like we have a bunch of text data. We can use compression. We can use the duplication because there are a bunch of copies of the same files. The ability to take snapshots to point you back in time. It's a nice feature to have, of course. The file system needs to be scalable, so it could be easily reduced or expanded as needed. And of course, as any file system, it should be compliant with CIA, so confidentiality, integrity, and availability. If we could get this for free, that would be great, and we basically can. And we can get enterprise file system that is ZFS, that has a proven track record, and we can get it for free with OpenZFS on Linux. And ZFS, of course, as you know, it's a copy and write file system that merges logical volume manager, file system, and software rate all in one. It gives you the simplified administration, so you basically only need two commands, zpool and ZFS, and as it has great track records, enterprise file system, so it has proven stability and data integrity. It provides with data integrity checks and data failure detections, and also can self-heal. How does the layer looks like? So you have your bunch of disks at the top. You can mirror those disks in RAID configuration, whichever way you want it, and then you get the virtual device from a bunch of disks. These virtual devices that are called VDEVs are then added to the ZFS pool, and on top of that ZFS pool, you get your ZFS file system. On top of that, you create data set that you can provide to your customers or to your developers in our scenario. So basically, this is the traditional LVM works. This is something that we use in most of our Linux servers, and we have them almost thousands of them. And there is nothing wrong with that. Logical Volume Manager, in fact, works. You have physical devices. On this screen, you have SDA and SDB. They are basically physical volumes. Put the physical volumes in a volume group, and top of the volume group, you create your logical volumes, and then you can format these logical volumes with any file system that you wish. In our scenario, this is mostly we use XFS, but it could be X4 or anything that you like. And then you use your network file system like NFS for Linux or Samba for Windows to export the file system to your end users, that is developers. In our case, this is the OpenShift container platform. Okay, if you wish to migrate this to ZFS, you don't need to do any reconfigurations of the NFS or from the customer side, from the developer side. You only need to stop the workload, replace your traditional logical volume manager with ZFS. It has the similar layout. You now get we have explained. You have now we have ZFS pool. You have virtual devices, and you have data sets that you can then you can start the workload, and the developers don't feel the change at all. As this is enterprise file system, it sounds like alien technology, and in some ways it sounds a bit scary, but it really is not. You can with a couple of commands you can install it on your server without any issues. So basically, what you do is you install it. This is the example for the Red Hat Enterprise Linux. On the Ubuntu, you would do apt install. ZFS, you create the pool, you give it the RAID configuration. In this example, you have 2 disks inside the mirror. You create the data set. You set your quota, so on the same data set, in this example, 30 gigabytes, and you can add for write cache your additional device. Export, so network file system, also easy. Install it, enable it, start the service, set your ACL to share it with, in this example, 1 IP, 1 host. And then you, of course, you need to open the firewall ports for the NFS. Okay, what ZFS provides us with? For read cache, it uses adaptive replacement cache. For write cache, it uses ZFS intent lock and secondary lock device. They both speed up reads and writes. And most importantly, for now scenario, it gives you very good compression using L24 algorithm, the duplication ability to take snapshots, and it can self-heal by self-healing can be done live, or you can done it on demand, and then this is called scrubbing. It can detect if there are some problems on the disk, and then it could copy the device, the data blocks from the disk that have the healthy data to the ones that don't. And it's, as we have said, it's really simple to use. So for read cache, it uses adaptive replacement cache, and what it basically does is it needs a lot of RAM. You must be aware of that, because it stores most recently used pages and most frequently used pages inside the RAM, while the least recently used pages and least frequently used pages are erected from the RAM to your HDDs. If you are using old SIS or SATA devices, it is advisable to use layer 2 cache in the form of SSD to speed up, to extend your RAM in fact. So we have said that ZFS is a copy on the write file system, but what does this basically mean? So in a traditional file system, you do modifications or alterations of data blocks in the way that when you need to modify a certain block, the modifications are done in place. So you can see that data 1 in this example becomes data 1 rewritten. So if anything wrong happens during the write phase, the alteration phase, you could get corrupted file system. So this is something that you don't want to happen, but it has happened to me a couple of times. It is not fun, trust me. But okay, so copy on write file system does this with each alteration or modification of data block. The ZFS writes a new copy of that data block, and it does not touch the old data. So if anything happens, it just updates the block pointers links to the new data. If anything wrong happens, you always have your old data blocks intact. So data 1 becomes data 1-1. Because of this feature of ZFS, you can do snapshots. So you can do snaps of your data in certain point of time. So you have your ZFS file system. You can take the snapshot of the current state of the file system, and the snapshot is done instantly. You don't feel it, you don't wait for it. Snapshot becomes read-only. So those data blocks are not rewritten. They are not deleted over time. But you must be aware, if you go back, you will not be able to go. If you go back to past, you will not be able to go back to the future. So Dr. Emmett Brown will not be able to help you. You will stay in the past. You will stay in 1955. The snapshots, of course, are read-only. You can mount them. You can copy the data back to the ZFS live file system. Or if you need to modify the data, you can promote the snapshot to the clone, and then you can alter your data and promote it back to the live file system. So this is very convenient and very easy tool to use. In our scenario, what we did and what we utilize the most is the compression and duplication. We all know how compression works. In fact, we know how the duplication works, but compression, as you know, in this we have an example. So you have blue and yellow data blocks. Let's say blue blocks are text files, yellow data blocks are binary files. They are easily compressed. If you compress the blue blocks by 70%, you can see that compression is done in real time before the data blocks are basically written to the disks. So there is no compression ad hoc in this place. And if you compress the yellow blocks by 50%, you go from 600 gigabytes to 530 gigabytes. This is compression alone. The duplication works by if you have blocks that are repeated on the disk, the ZFS writes only the blocks that are different, and in the duplication table, it stores the pointers to the right blocks. So in this example, you can see it on the screen. There are four different data blocks, and we deduplicated them by 2/3. So from 600 gigabytes, we went down to 200 gigabytes, and then if we combine the results, and you of course can use compression and the duplication in tandem, we went from 600 to 130 gigabytes. So let's take the results that we have achieved in our environment by using compression and duplication. So compression ratio was 1.7. The duplication ratio was 4.8. So we started with 27 gigabytes of data. When we utilized the compression, we went down to 15 gigabytes of data, and then on top of that, when we utilized compression and duplication, we went to 3.28 gigabytes of data. So this is very nice reduction, very usable indeed. But there must be some downside. Of course, you must pay this in some other way. And basically, when you see the results of writes and read and writes times, you can see that this above example is XFS, this down is AFS. Read times for both file systems is the same, 37 seconds to read the 588 megabytes Node.js projects, but that has a lot of small files, in fact 61,000 files. But when we did writes on the ZFS were faster, but not much. On ZFS side, there was a 44 seconds write, so 9 seconds was different. But because we don't have in our environment is not very write intensive, this is basically very acceptable for us. And you can explain this difference in compression and duplication that are using additional time to do. So now, before the closing, I will give back to my colleague Dario. He will talk to you briefly about security. And thank you for your time. Yeah.
Thank you. We will briefly talk about security, but we won't talk about security on the cloud side because those things should be sandboxed. But because you're using your browser, the extensions are quite vulnerable, and you have to pay attention on what extensions you're actually installing. So this should be the one thing that you should take from this lecture. And to conclude, it's some word of encouragement. Resistance to change is normal, but as we see that the Adobe bought Figma, so the cloud path is inevitable. So there is no turning back. The number of integration errors are completely reduced. There is increased security because the source code isn't stored anymore on the workstations, and there's no need for admin privileges. And at the end, think big, because you always have to design your system for much more users, and then you will get those innovative ideas. And to close it up with the popular quote from the Casablanca, I think this is the beginning of a beautiful friendship.